Okay, so today we're going to talk about simplifying and evaluating algebraic expressions, and we already did evaluating expressions in class. That's when we watched the 6th grade video 110. So for future classes, if we haven't watched it in class, at this point you would click out of this video and go and watch the 6th grade video 110, because that will show you how to evaluate the algebraic expressions. But for now, if you click out of this, watch the other one, come back to this video, we're going to talk about simplifying. Okay, so to simplify simply means that you will do everything you can in the problem until you can do no more. And here I have a very simple example for you guys. That is basically 2 plus 2 equals 4. You could do 2 plus 2, you ended up with 4, you cannot do anything else. So simplify just means solve until you cannot do anything else. So the next thing you're going to need to know is like terms. Like terms means terms that have the same letters and the same exponents. So I'm going to show this to you down here. So I have 5x minus 2y plus 3x plus 8. So here I highlighted with red the two terms that have x's. So 5x and 3x, they match because they both have x's. 2y right here in blue, it does not have anything that matches it. So 2y is just lonely by itself. And then the 8, right here in green, doesn't have any letters with it, so also it's by itself because it doesn't match anything. Now, we also talked about that the positive and negative sign in front of the number belongs to that number, and I mentioned to you that everything will get a lot easier once you stop thinking about them as pluses and minuses and start thinking about them as positives and negatives. So you have to be careful that this 5x right here is positive. This 3x here has a plus sign in front of it. That plus sign goes with it, and it's also positive. This 2y right here has a negative in front of it, and that will make it negative 2y. And this 8 has a plus in front of it, which will make it a positive 8. So once you kind of get that through your brain, let's see it as an example. So I have it as a first example on this slide. So remember, 5x and 3x match. Positive 5x, positive 3x. If they match, I can actually add them the same way I would add normal numbers without the letter. So it's like if I had 5 apples and then have 3 apples. At the end, I'm going to have 8 apples. So it's going to be 8x. Then I have this 2y that's all lonely by itself. I cannot combine it with anything else. Remember, it has the negative sign in front of it, which means I have to take that negative along with me. So it will become negative 2y. And then this lonely 8, it has a positive sign in front of it, so it's plus 8. I'm going to take that with me, and then that with 8x minus 2y plus 8. Nothing else matches, so I cannot do anything else. So this is as far as I can go simplifying it. So next one right here. I cannot do x minus y inside the parentheses because x and y do not match. They're different. So I need to think to myself, how can I make this a little bit easier on the eyes? What I can do is I can distribute this negative 9 through the parentheses, which means I'm going to multiply it by everything inside the parentheses. Negative 9 times x will give me negative 9x, and then negative 9 times negative y, because remember, this negative goes along with the y. Negative times a negative gives me positive, so it's going to be plus 9y. And then this plus 3 on the end is just going to tag along. Now I can go ahead and see what matches. Negative 9x is just by itself because there is no other x's in the problem. And then I have positive 9y and positive 3y that match because they have y's. So my negative 9x will stay the same. And then my positive 9 and positive 3, I can combine them to get a positive 12. And then the y will come along. Let's take a look at this next one. First, I want to clean it up a little bit. I have these absolute value symbols here, so I'm just going to get rid of them. Anything that is inside the absolute value signs, when you take it out, remember it's going to turn positive. So I'm just going to rewrite this problem to make it look a little neater. So 4n plus 3n plus this 5 right here is going to be a positive. So I'm just going to take it out, bring it down as a plain 5, plus 2n plus 6. And then I'm going to see what matches. So I have 4n, which matches 3n, which also matches the positive 2n. So I can combine all of those. And then I have positive 5 and positive 6. This disappeared for some reason. So they don't have any letters. So I can deal with them together also. So let's see, 4n plus 3n plus 2n. So I can go ahead and add all of them up. 4 plus 3 is 7, plus 2 is 9, so that will give me 9n. And then I'm going to combine my 5 without any letters and 6 without any letters. Positive 5 plus 6 will give me positive 11. And at this point, nothing else matches, and that's all. There's nothing else I can do with it. And this last one might look a little bit scary at first, but it's not really if you just know what you're looking for. So 31, it doesn't have any letters, so it will match positive 5, which also doesn't have any letters. Then I have this 9n squared s. Well, here I also have n squared s. So this 9 and this n squared s right here, they match because they have the same letters and they have the same exponents in all the same places. Now, this n squared s, there's nothing in front of it, which means I can put in the 1, because if there's nothing in front of it, it's just an invisible 1. So I have positive 9n squared s and positive 1n squared s. So now I can go ahead and combine everything that matches. 31 plus 5 will give me 36. And then positive 9n squared s and positive 1n squared s, I combine them. 9 plus 1 gives me 10. And it's positive, so I put plus in front of it. And n squared s just comes along for the ride. And at this point, I cannot do anything else to this. This is in simplest form, so I'm done. So we'll practice more of this tomorrow, and that's it.